Okay, in this presentation we're going to look at set operations in Julia. I'm using Julia version 1.6.1 and obviously I am using Jupyter Notebooks. Now in the first instance we're going to look at sets as a type in Julia, but really I'm focusing more on operations, and they don't necessarily have to operate on just sets. They can operate in vectors and tuples and so forth. But let's just set up a very simple set here. Okay, S equals set 1, 2, 3. Let's just run that. Very straightforward. It just actually defines an object S as a type set. A set here which is comprised of integers 2, 3, and 1. Okay, I'm not really sure where the order is there, but anyway, it doesn't really matter. So the next thing is, let's just check that set, and it's going to confirm that it is a set of type integer 64. I'm going to just mix it around a little bit. I'm just going to put in any. Okay, and let's run it again. We still get a set, even though it's going to be comprised of objects other than integers. In fact, it doesn't have to be any particular type of type involved in the set. We can mix them up, and let's just check the type of that set of any. Okay, now what I'm going to do is simplify things a bit. We don't really need to use sets to use set operations. So what I'm going to do here is set up an object called A, which comprises the integers 1 all the way up to 9. In fact, sorry, I'm missing 1. I'm missing 7. I'm just going to sort of go back and forth here a little bit. Let's just check the type of that. And there we are, a vector of integers, okay, which is an alias for an array. Okay, that's interesting. Okay, we're going to try this with tuples shortly. I'm going to just create a second object here, and it's the same type. It's an object called B, and it is the same has the same type as A. And here, in this case, it's going to be a 5-element vector. Okay, it has some of the same numbers, but same elements, some of the same members, but some different ones as well. Now, anyway, here is the main set of operations for set theory: union, intersection, set difference, and also check if something is a subset. I'm going to just sort of change the numbers a little bit back and forth here, just to sort of try out some operations there, just to see how it works. So let's try out the union of A and B. There we are. We have all of the integers from 1 to 10. B has some additional numbers such as 7 and 10 that are not found in A. Let's look at the intersection. Yep, there we go. 1, 5, and 9 are in elements of both sets. And let's look at the set difference there. Okay, so we have the set difference B from A, or sorry, A from B. Okay, which means that there is the elements B and elements 7 and 10 that are found in set B, not found in set A. And let's just reverse the process there. See what is in A but not in B. 2, 3, 4, 6, and 8. Okay. Now, what I'm also going to do here is the symmetric difference. Okay. Now, this is essentially a union of the two set differences. Okay. So, this is the union minus the intersection. So, it's found in one, elements that are found in one or the other, but not in both. So, union, intersection, set difference, and symmetric difference. Those are the 4 key set operations there. What I'm quickly going to do here is just check, can we do the whole thing with tuples? Okay. So I'm just going to slightly change things here and just see, does it work for other types, not just vectors? Can we use it in objects that we might use a lot for mathematical purposes? Okay. So we have the tuples A and B. And let's see if we can use these same operations there. Yep. Okay, union of A and B. Intersection of A and B. Okay, you notice that the type is a vector still. Okay. And the symmetric difference. Okay. We want to see if a set is a subset of another set, okay, is B a subset of A? It's not going to be in this case because of the set difference from B to A. Let's just see what happens if I take, just change it slightly, 1, 5, and 6. Okay, I'm just going to re-express B as 1, 5, and 6. And is it a subset in that case? Well, A is 1, 2, 3, 4, 5, 6, 8, and 9. And B is 1, 5, and 6. Okay. So let's just look at the intersect of A and B. Now this is permanently going to amend A such that it is... Okay, intersect. Okay, that doesn't work for tuples. But anyway, I think I have to change it back to vectors. Let's do that very quickly. There we go. 1, 5, and 6. Okay, so that only works for vectors. And let's just see what that does to A. It actually updates A to take the values of the intersection of A and B. Okay. So that's a quick look at set operations and looking at multiple types and how they interact.